We start with the second part of the second chapter of Guyton, namely vestibular sensations and maintenance of equilibrium. As you know, as you would remember, that we did descending motor tracts and their clinical features, lesions and all that sort of thing in the last few lectures, over the last 2 weeks, if I remember, right? So from today we will, welcome back, walaikum assalam. Why do we like to know about the vestibular apparatus and all this thing? Is because we want to know how does the body maintain its equilibrium and balance during A, when it's stationary, and B, during the movements. So when the body is moving, it's doing its various movements and motion. The key thing in the background is that it needs to maintain its equilibrium and balance and posture, all of which depend on it's stable. So its stability through the motion, various motions it has to go through on a daily basis, depends on vestibular apparatus. Vestibular apparatus in the inner ear and its coordination with vestibular nuclei of the brain stem. So you will be studying these two things when you study this lecture and when you read it from Guyton. These are the two things that you will learn. One is the inner ear structure called the vestibular apparatus and its detail, and how it connects with the vestibular nuclei of the brain stem. All right? Give me a second. Okay, so this is about that. The learning objectives, we will look at the anatomy of the vestibular apparatus, then we'll look at what these two things are, utricle and saccule, and then we will describe the functions of semicircular canals. So these are basically three things. The vestibular apparatus comprises of utricle and saccule and semicircular canals. Okay, these are three things. These are lumped together as otolith organs. So these are both under the heading. Welcome back. So once again, vestibular apparatus comprises of the otolith organs, which comprise of utricle and saccule. We'll learn about this shortly. And the other component is semicircular canals. All right. Just give me a second. I forgot to turn on the Zoom. Okay. I'll go blank in a bit. Connect Zoom and then you'll be able to see it. Just hang on. Okay, here we go. Okay. So, as I was saying, we will start with the anatomy. So this apparently complex looking diagram is not actually very complex if you look closely. Now look, this is the entire ear. Okay, this is the pinna, this is the outside of the ear, the external auditory canal, what you call the eardrum, and all the machinery that involves in the hearing. So let me just get that out of the picture by just pointing it to it. Whatever this stuff is, the external auditory canal, okay, then you have the eardrum, then you have the malleus, incus and stapes, and this cochlea. with the round and the oval window and all that sort of thing. This is not the focus of this lecture. Okay, this entire machinery, this and this snail-like thing called the cochlea, this is related to hearing. Okay, now hearing is a special sense. Welcome back. All those are special senses. What we are concerned primarily is this stuff here. Okay, this not this, not the cochlea, so not this, but this thing here. So to be precise, it's this guy here. This is where the vestibular apparatus lies. Okay, and if I just give you a hint, this is where the otolith organs reside, and these are the semicircular canals. The 3 semicircular canals you can see probably. This is 1, this is 2, and this is 3. Okay, we will look at magnified views in a bit. While this bland flat thing hosts the otolith organs. Yes, do you now see what we are concerned with in this diagram? Feedback, please. Right. Are there any questions? Okay. Fine. So now from this point onwards, we will be looking at this picture, but in a bit more detail from the vestibular apparatus point of view. Okay. So as you can see in this picture, we have taken out the inner ear contents. We are not concerned with the external ear or the middle ear. We are only concerned with the inner ear contents. And as you can see, this bit here, this whole thing, welcome back. Forget about what's written here. Just concentrate on what is drawn here. Okay. Let me walk you through it. So this cochlea business, this is not our cup of tea in these lectures. This is to do with hearing. Okay. It's this stuff here, right here. This is what the vestibular apparatus is. And if you remember, we mentioned 2 words, utricle and saccule, as otolith organs. Right? These are otolith organs. Okay. And then we had the semicircular canals. Right? So this area, this whole thing, this area here is referred to as otolith organs, and it comprises of this swelling, this area called utricle, and this area, this swelling called saccule. You will notice nothing is random here. You will notice that they are at a certain angle to each other. This is important. Okay, we will look at this in a bit. Then you have the semicircular canals, which seem to originate, at least anatomically, from the utricle. As you can see, this is one semicircular canal. This is the second so this is the anterior semicircular canal. This is the horizontal or lateral semicircular canal, and this here behind is the posterior semicircular canal. All seem to have a sort of a close proximity with the utricle component of the otolith organ, while the saccule seem to be minding its own business a bit separately. Yes? Are there questions? Is this okay up till now? All right. Now let's introduce the functions now. Okay, can you see this bit here? Can you read it? All right. So let me magnify it a bit. So here. Okay, welcome back. So as you can see, VA is vestibular apparatus. Okay, VA consists of utricle and saccule. We know this now. It's called the otolith organs and semicircular canals. Otolith organs, i.e. the utricle and the saccule, they detect linear acceleration, linear. While the semicircular canals, they detect rotational or angular acceleration. Now, why didn't we mention speed here? Why have we mentioned acceleration? Is because of a very clear-cut reason. By acceleration, we mean rate in change in velocity, isn't it? So these receptors, they are basically receptors. Now we are going into the physiology of things. Utricle and saccule are receptors. This is a receptor. This is a receptor. What do they do? Receptors do detect things, right? Because they are receptors. So what they detect is linear acceleration. Okay, utricle and saccule detect linear acceleration. What do you mean by linear acceleration? Very simply, if you sit in a car, okay, and the car is stationary at the moment, and now the driver starts to drive it. The car starts moving in the forward direction, whatever that forward direction is. So whatever forces that are applied on the body, especially the head and neck, they will be detected by this otolith organ setup as linear acceleration in a certain direction. Okay, so when the car will start moving, the rate of change of velocity will change, right? Because it was stationary. Welcome back. So I was explaining to you acceleration. So rate of change of movement is high or is prominent at the start of this movement, correct? As the car develops a certain velocity and is constant, then the acceleration bit becomes constant, right? It doesn't change. It becomes less dynamic, as somebody mentioned, dynamic. Less dynamic. Yes, do you remember your physics? Feedback. Okay. But did you understand my point? When the car starts to move, okay, in the initial part, the rate of change of velocity is more. So acceleration will be more. Acceleration will be more. As the car achieves its optimal or its road appropriate speed, and it just stays there, it doesn't change. So say it goes to 60 kilometer per hour and stays there at 60 kilometer per hour. Okay, the driver does not push the pedal or brake the vehicle, it just stays there at 60 kilometer per hour. So there is no change in acceleratory forces at that time, correct? So during that time, you have, let's say this is the second phase. The first phase was when it started to move. The second phase was when it became constant. And the third phase is when you have arrived at your destination and now the driver has to apply the brakes to bring the vehicle to a halt. So when that happens, you have, first you had acceleration, then you had constancy, then phase 2. Phase 3 is deceleration. It's slowing down and the rate of change of velocity again is there, but in the negative direction, or we call it deceleration, right? Feedback please. Welcome back. Come on. More. Any questions? Okay. So these receptors, the ones, these receptors, the ones which are related with, are supposed to detect linear acceleration, i.e. utricle and saccule. I'm giving the lecture in a way that you learn it and you remember it, hopefully. Okay? You don't need to do a lot of effort reading the material. Once you start reading the material, you will actually find out that you remember this stuff. Okay? So that's why I'll keep on repeating this so that you remember. Utricle and saccule, linear acceleration. So they're active all the time because your head and neck is slightly moving. It's not exactly stationary. This is news for you. Your head on top of your neck is always bobbing a bit like this. It's not stationary. It's bobbing. Just like those small plastic thingies in those toys that people sometimes put in their car on the dashboard, which keeps on moving. They have a spring in the neck and the body that puts on the dashboard, and then they have wobbly head. Yeah, bilkul. So we too have wobbly heads, okay, but the wobble in normal people is very, very subtle. All right. But since these receptors are constantly at work, they do apprise the brain of any significant deviation from that wobbliness. If that deviation increases from the normal baseline, then their firing rate increases. It's the standard receptor related information that you've been studying for months now. Started with baroreceptors, remember? We said that the baroreceptor normally discharge at a basal rate, and it's only when the blood pressure goes up or down is. Welcome back. We spoke about the muscle spindle. We also said the same thing, that in muscle spindle, again, it is discharging constantly. It's when the length changes, it discharges more, right? Same technology is here. It discharges all the time. However, when the body is actually in acceleration or deceleration, it discharges more or decreases the discharge more. So during acceleration scenarios, it discharges more, becomes more active. In deceleration modes, it drops its deceleration beyond normal range. The whole point of this discharge is that what is it discharging to? What is the destination? Go on. What are these receptors connected to? I mentioned it in the intro. Yes, Mavia. But let's not get ahead of ourselves. I'll explain this. Vestibular nuclei, Hafsa. Very good. Very good. Sir, in constant firing rate reaches baseline again. Yes, baseline and below baseline. Or baseline. Yes, you're right. So during acceleration, it will go up to a point, and deceleration scenarios, it will try to come towards the baseline. Okay. Okay, I'm not asking you about the hair cells, guys. I was just quizzing you. Where does this signal end up in? The answer is vestibular nuclei of the brainstem. Okay, the hair cells are right here. They are generating the signal, as we'll find out very soon, inshallah. I'm saying, where is the signal going to? So this whole thing, this whole setup is connected to the vestibular nuclei of the brainstem. The vestibulocochlear nerve, heard about that? The vestibular component of that nerve takes signal from the otolith organs and the semicircular canals and takes it to the vestibular nuclei of the brainstem. Welcome back. The other copy is sent to the vestibulo-spinal descending tracts, which we discussed at length in the last lecture. Okay, so you know the connections now. If there are no questions, Semicircular canals is again, it detects rotational or angular acceleration. So it's the same tech, hair cells and all that sort of thing as the otolith organs. However, the main difference is that it, instead of linear, it detects rotational. So this example would be when you sit in a swing which is going round and round in circles, okay, or you do a somersault, okay, or you roll over. So anything which puts the body in a angular or rotational acceleration or deceleration will trigger semicircular canals. Anything which puts you in a horizontal linear acceleration, then otolith organs will be triggered. Capish? Okay. So there are no questions. We move along. Right. Okay. Can you see this? Is this view okay? I have everted my screen a bit. Okay. Guys, where are you? All right. So again, we are not concerned with the cochlea. Let's just concern ourselves with these. Now this third slide, if you see that on this slide, we are zoomed out. We zoom in. We really zoom in. Okay. And in the next, we further will zoom in on specific things. Okay. So we are zooming in from outside to inside. Now the difference between this diagram and this diagram is that we are focusing now, welcome back, the signal that is taken or gets generated during acceleration, various acceleration scenarios, okay, and is sent to your vestibular apparatus, okay. So as you can see, this structure here, this structure is the receptor of the receptor. Yeah, if you understand that. This here, this guy here, and this here. Okay. So this is what we are concerning ourselves with now. We are looking at saccule. Where did he hasn't labeled the utricle? He has, yes, he has. So just look at the stuff which I have labeled. The rest, this thing here, for this bit of the lecture, just forget about it. Forget about semicircular canals. Just focus on the otolith. Right? Familiarize yourself with utricle. This is the utricle. This right here. Okay. This is the receptor part of the utricle. This roundish thing is the saccule. Okay. And this is the receptor part of the saccule. Okay. This is the receptor which has that hair cells that people were talking about. Okay. So these are those receptors which have those hair cells which will detect, which will generate the signal and send it off, right? More on that in a bit. Just look at the orientation at the moment, the location and the orientation. Location you are now familiar with. Utricle sits at the base of all these semicircular canals. So you know now this area is utricle. This is the receptor of the utricle. And attached to, very close to it, is the saccule, and this area is the receptor of the saccule. Okay? The receptor is, welcome back. So the name of the receptor is Macula, okay? And collective is maculae, along with this word statoconia. I'll come to this in a bit. Statoconia. Okay. So now this is where we are now going into a bit of detail. Okay, so saddle up. The utricle and the saccule are at a certain angle which cannot be shown here because this is a two-dimensional diagram. In 3D model you will be able to appreciate it, okay, or imagine it. You will have to imagine it for now. The utricle and its macula is arranged in a way that it will detect linear horizontal plane acceleration and deceleration. Saccule will detect vertical linear acceleration and deceleration. So very simply put, utricle along with its receptor will be triggered in the car example that I just mentioned. Car, horizontal acceleration, slowing down, deceleration. Yes? Saccule, come up with an example for saccule. Go on. Let me see imagination. How do you imagine this? Shabash, Abdullah. Shabash. Solat, excellent. Abdullah, of course. Jumping, yes, true. From a building, was completes the sequence. Well done, was. Let's not jump from anywhere for now. Let's just take the elevator. Okay? So, elevator is a good example. So, anything vertical going up or down, an elevator, will trigger the macula of the saccule, while anything horizontal will trigger the macula of the. Does that mean getting on an escalator would trigger both? Oh, no, it will trigger. Okay, so this is an overview of the function now of utricle and saccule. Utricle both deal with linear accelerations. That's one thing, but there is a slight difference. Main difference is the plane of linear acceleration. Which escalator moves forward, Abdullah? Maybe there's a slight movement. I don't know. I didn't concentrate in that. Whichever elevator I've been in up till now, and there have been quite a lot of elevators, it only moves in the vertical direction. Maybe it does a bit forwards or whatever, but you understand. Okay? Automatic stairs, escalators, Hanji. Yes, Afsa, well done. Okay, let's not start a fight here. Okay, let's focus. So these are examples to clarify what these organs do. Okay, in real world, of course, there are no exact hard and fast rules of axes. Okay, I'm just giving you an example to tell you that utricle is to do with the horizontal, while saccule is to do with the vertical. If it's in between, whatever movement is in between, then both will be triggered appropriately. Okay? Yes, Absa, if a movement has a horizontal component, then utricle's job is to detect it. Detect the displacement of the head when the body is moving along a horizontal axis. If the body is moving along a vertical axis, then it's mainly the job of the saccule, the macula of the saccule. Okay? So, if I may demonstrate it to you, if this is the macula of, say, the utricle, okay? And let me just show it to you like this. And this is the macula. Welcome back. Yes, beta, it can work simultaneously if the movements are in between these two axes. So there's a component of horizontal and there's a component of vertical. Okay, to give you that answer. Now, I am demonstrating how is the macula arranged. Mavia? But if flying has again both components, when you're on the runway, it's different when it's the, let's break it down. When the plane is on the runway and it's firing up, it's linear acceleration, isn't it? When it's running on the runway, it's about to take off. When it actually takes off, is an interesting thing, because when it takes off, it's in between those two axes, isn't it? It's not rotational, it is still linear, but it's between the horizontal and the vertical, right? But when it goes up and becomes horizontal again, then it's again horizontal. When it rotates, commercial airlines don't rotate a lot. They only rotate when, and actually they don't rotate at a very high speed anyway. It's the jets, the fighter jets that do that. So in in fighter jets, I would say the pilot's semicircular canals will be at motion, at work when it rotates. Okay. Okay. May I come now to the orientation of the receptor, please? Okay. So, as I was explaining to you, this is, let's say, this is the macula of the utricle. This is the utricle. I'm telling you the orientation of its macula. This marker here, let's say, this marker here is the macula. Okay? So, all the hair cells are arranged in this direction. Can you see this? I hope you can. All the hair cells are in this direction. Did you get that? Abdullah, concentrate on the screen. Yes? Come on, tell me. Welcome back. This is the utricle, its macula, and arrangement of the hair cells are like this. Okay? So, when this thing will move like this, or this. So, in the horizontal, when it moves, the hair cells which are placed like this, they deviate either backwards when it moves forwards or forwards when it moves backwards. Did you get this, what I just did? If the hair cells are arranged like this is my index finger, if they're arranged like this, right, when the whole thing goes forwards, they will deviate, they will be pushed forwards or backwards, or when it goes backwards, they will push forwards and backwards. Alhamdulillah. So you understand that. In saccule, it's like this. So the hair cells are arranged like this, in this direction. So when the saccule in the vertical direction goes up or down, the hair cells will deviate accordingly. Yes? Okay. Questions? This is done in an awesome way in a live class, but I think we get the gist. Okay, Aisha Tariq, you are roll number 17. This is not a roll call, bete. Sahi hai? Questions? So just a thought. So the saccule would tonically discharge then. In a scenario where, in its scenario, isn't it? It will increase when the axis comes. Yes, bete. Both have macula and statoconia. Macula is the receptor part, statoconia. When we say normal standing, we mean that there is no acceleration, so there is nothing to detect. Okay? It will just tonically discharge, uprising the head and neck, and mark these words. At rest, the otolith organ and the semicircular canals, they apprise the CNS that, hey, the head is on top of the neck. Nothing to worry about. Okay? And then when you start spinning or you start to get in a car or in an elevator, whatever axis you put your body into, the forces that act on the head, that those are detected by these receptors and conveyed to the CNS that look, the head is on top of the neck and dash dash dash. This sort of acceleration is happening in this direction along this axis and so on and so forth. Okay? Look alive, people. ठीक है? चलो. Cool. Okay. Now, chalo. So we've done this. We've done this. Why is it? Sorry. Acha, sorry. I have to decrease magnification. Chalo. If this is done, so in the next slide, before I put it on, I just want to recap that next slide, what we'll discuss. Now we'll go into details of this receptor. So again, let me just for recap, I showed you this, then I showed you this, which is a magnification of the previous one, then I showed you this, which is a elaboration of the previous one. Now the next slide will focus on the macula and the statoconia itself. Okay, welcome back. Since the format of the next slide is entirely different, you won't be shown this diagram again. So I want you to have a good look at this diagram. Okay, just please remember that we are concerning ourselves with this part here only. This bit here, okay, this bit, which comprises of the utricle and the saccule and its receptor component called the macula, along with this thing called the statoconia, which we'll discuss now. No bete, not crista ampullaris, it is to do with the semicircular canals. That's why anything outside of the red box, we are not concerning ourselves at the moment. Yes? This is also where this seemingly benign lecture will turn a slightly more complicated curve. So I hope you've had your breakfast. Okay? Or maybe you want to go quickly want to fetch some tea or whatever. Okay? Because this is from this slide onwards, the slides are less, but they have a, let's say the interesting bits are coming now. Okay? Are we ready? That was a question, guys. Are we ready? Okay, let me hear it from the other people, not the usual suspects. Who are the other people here? The same names. Other 55. Bachon? Yes, thank you. More. I want to see more names. I want to see who you guys are. I don't know these names. I just know the frequent flyers. All right. So, here we go. Now, this business, by the way, you've done. I've also mentioned hair cells and supporting cells, I'll explain. But this bit here, you've already done. I want you to concentrate on this little diagram here. Okay, I'll magnify it in a bit. Hold on. Kyun ji? Can you see this diagram loud and clear? This whole diagram? Sahi hai? Cheek? Right. Okay, now I'll be slow, okay, to give you orientation. Bachon, this is the hair cell. This is one hair cell, this is another hair cell, another hair cell, and so on and so forth. What he has done is he has taken a piece of the macula. He has taken a piece of the macula and magnified it. Okay? And in these, you can see these hair cells. This is a hair cell, this is a hair cell, and so on and so forth. Okay? By supporting cell, he means this orangey stuff. You can see the nucleus. So these hair cells, which are very fragile, are supported by, well, the name signifies supporting cells. Okay? I won't go into the anatomy because it's not an anatomy class, right? So the hair cell, duly supported by its supporting cell, is propped up, is literally sort of, as you can see, if you can appreciate the boundary of the supporting cell, look at this boundary. Okay, look how it's sort of cupping the hair cell here. Do you see? Do you appreciate the two supporting cells, 1 and 2, sort of physically holding it up, okay, projecting it, lifting it up. Yes? Welcome back. Yes? Feedback, feedback. Okay. सही है? Okay. Now, point number 2 to observe is the nerve fiber. Nerve fiber. So the nerve, each hair cell, or before the nerve fiber, let me just tell you, let me just bring your attention to these finger-like projections. If you observe closely, we are here. This is what I want you to look at. Yeah. These are the cilia, finger-like projections, which project from the top part of the hair cell into this sort of gray area. We'll talk about the gray area in a bit. Okay? So, hair cell with its cilia or the hair of the hair cells are projecting into this grayish area, this jelly-like grayish area. Okay? This is what a typical hair cell looks like. Remember, this same type of hair cell is in the cochlea as well. And if you understand these topics, if you understand one topic, you understand the rest. It's actually very nice. It's ingenious. It's brilliant. The way this technology is used to generate action potentials. Okay, because look, at the end of the day, you have to generate an action potential because CNS does not understand any other language but electrical currents, right? So this is the beauty of the creator, that he uses the hair cell and the, welcome back. So the deviations of these cilia either depolarizes this cell or hyperpolarizes this cell, i.e. either switches it on or switches it off, such that the connecting nerve which abuts the base of the hair cell either gets stimulated or gets inhibited. There you have it. The whole sequence again in one sentence. Who got that? I summarize like serious parts of information in a sentence. But did you get it? I will explain. I will repeat it. I'll keep on repeating it. It's alright. Hafsa, you weren't listening. Shararte karti ho. Focus. I'll repeat it. Okay. Fine. Okay, maybe a few got it. It's okay. I'll repeat it. So, listen up again. Look, This is Mr. Hair cell. This is Mr. Nerve. Okay? This here is the vestibular apparatus. Okay, sorry, can't see the vestibular apparatus. Yeah. So this is the vestibular apparatus. Okay, I've just made it simplified version. This vestibular apparatus. This is where the CNS will calculate where is the head on top of the neck. Okay, but for this area to calculate, it needs input from the nerve fiber, the vestibular part of the vestibulocochlear nerve. All right, यहाँ तक ठीक है? So whatever signal these nerve fibers will bring to the vestibular apparatus, the vestibular apparatus based on that, or let's make it. I feel like doing this right here. Right. Welcome back. This is the nerve fiber, and its designated area is here, right here. Right. This nerve fiber, its designated area is here. Then this, and this. Okay? It's a simplified diagram. Okay? So each hair cell through its respective nerve fiber is represented in the vestibular nuclei, specific places in the vestibular nuclei. Okay, so make this concept. Each fiber goes to its designated area. Are you with me? This is crucial now because I've decided to explain the whole damn thing in one place now. So the rest of it will be just chemistry for you. Will be easy peasy. Tausif, thank you. Well done. Why? Seema, is that a question, bete, or is the yes? Thank you. Yes. Okay. So, I mean, you can also look at it. I'll put it in another way. You can also look at it as let's say Wi-Fi leads or internet leads, which come through these nerves representing each hair cell, and they link up to a specific area in the vestibular nuclei. So let's say if this is A, B, C, D, E. Okay, I'm just giving you an example for you to understand how the whole thing works in an overview sort of thing as well. So let's say if hair cell A, B, and C, they discharge their hair cells. Welcome back. YouTube is very naughty. Let me repeat. I was saying, let's take a scenario where cell A, B, and C, they have depolarized. D and E haven't. They actually have hyperpolarized. Okay, I'll tell you a scenario where this may happen, but just stay with me. Okay, so 1, 2, and 3, these nerves will obviously fire up the designated areas, their designated areas. Solat. Hanji, Solat. Yes, and yes. This is where I want to bring you. This is that thing that is not written in books like this. It has to be imagined. These are physical text written in books, but you have to visualize it. And we are visualizing it right now, right? Something is happening. Good. So, each of, so A, B, and C, these 3 designated areas will be stimulated inside the vestibular nucleus or nuclei, right? However, D and E designated areas won't. They will actually be inhibited. Okay? Are you with me? Final point coming up. So say Ameen with me. Come on. Right. One person. Right. What about the rest? Come on. Come on. Where are the Abdullahs of the class? Where are the Hafsas of the class? The rest of them? But it's not possible for all of you to understand. So I know whatever is happening right now is just a filler. I'm not kidding myself here. What I've just explained is complex. I don't expect everyone to understand, but if you have done it, kudos to you. Well done, mashallah. I'm very happy. Now, if you've understood what I've just explained, let me now just tell you that if you're sitting in vestibular nucleus, three buttons, 1, A, B, and C, will turn on, while the two bulbs of D and E will be switched off or dimmed. Let's say dimmed, not switched off. So these three will be brighter. Welcome back. You hate YouTube for doing this, isn't it? So from this, you're sitting in the center, the nerve center, the business center of the vestibular nuclei, and you're receiving this input. Three bulbs are brighter than usual, while two bulbs aren't, right? There are no bulbs, guys. This is just a way to explain, okay? From this, you will calculate that, it means that such and such hair cell have stimulated, because you know your stuff. You know your stuff. You know what this bulb means. This bulb means hair cell A. This bulb here means hair cell B. Right? So when specific designated areas representing designated hair cells, they get stimulated while others are phased out, the vestibular nucleus is ideally engineered to make sense of it. How? In simplified way, it will obviously make out which hair cells have been stimulated. From that, it will calculate that, this means that those hair cells that are oriented in this particular area of the macula, they have been triggered while the others haven't. Which then means that this motion would have been done to the head. I'm taking a pause now, a dramatic pause. There's no way in hell you all can understand that over the internet. But if you have, something special has been done today. Last thing. Bete, last thing was everything. Which last thing? When... Acha, theek hai. Hold on to that question. Let me just quiz the others. What about the others? Acha, rest of you, welcome back. Okay, cool. All right, it's fine. So once again, the macula bit. Okay? I obviously can't repeat the same thing because it's live and it's fresh. I'll say it in another way. Okay? The other way is coming up. Imagine, if you may, that the vestibular nuclei has a map of all the aspects of the macula. How about that? Now, Hafsa, now listen to this new rendition, the new version of the same thing, so that it just covers up the whole aspects, hopefully. And of course, then nothing can replace personal reading, as I always say, right? So vestibular nuclei have an actual map based on these designated termination of all the fibers of the vestibular nerve, right? It has a map of these, the entire macula of the otolith organs. Okay? It has a map. All it needs to do is look at the pattern of action potential generated in certain parts of the map while the rest go quiet. And from these differentials, yani this sector of the map is blinking. It has been stimulated, while this sector of the map is not. From this difference, it calculates the precise axis the head has been subjected to move in. Yes? Chalo. Okay. I think we deserve a well-deserved break now. Okay. Go have some. Yes, Abdullah, mashallah, Abdullah Javed, you have put it very nicely. Thank you very much. This is indeed the intricacies that solidifies our iman, that there is definitely a creator up there. I mean, imagine this technology. Just imagine. Imagine this is what a baby has by birth. The baby obviously is still developing these pathways. You know, all of this tech is present. It's just the myelination of these nerves which is not. Hence, the baby is a bit wobbly. And as soon as the baby starts to crawl or walk and take its weight on the heels, these myelinations by that time are still developing. When they develop, it starts to hold its head. Yes, the tech is there. It's just developing, obviously, right? So it truly is amazing. Okay. So with this, we'll take a break. By the way, we will finish, inshallah, the Utricle and Sacule business today. Tomorrow, I'll take up Semicircular Canals. And the very, very important tutorial. I was personally disappointed on the feedback I received from my colleagues during your last tutorial. So please don't do that. I will personally be following up your progress in the descending tract wali discussion tomorrow in the tutorial. I might actually be in one of them. Okay, so I'll be a surprise to one of the groups, or maybe all of the groups. I'll just pop in. So, and it's not just my pressure. Okay, you're not kids now. You're adults. Okay, please study this material. This is complex stuff. Okay, this is very complex stuff. You get a high during the lecture and you think it's gonna stay. No, but news flash for you. It doesn't work like that. Okay, it vanishes unless you consolidate it with personal reading. Okay, so tomorrow the descending tracts and all the clinical stuff that welcome back. I don't want to hear from them that look, the class wasn't prepared. Okay, this is an insult. I hope you understand these things. Okay, so today is a busy day for you. Today you'll consolidate this after the lecture is over, and you will read up the Motorwala stuff. Okay. Bete, I don't know. She's still away. I'm in touch with her. Her parents are, mashallah, stable now. But I don't know a date. Okay. Chalo. So with this, let's take a break and reconvene in a bit. Assalamu alaikum.